Support for today's Heat Treat Radio episode is provided by Nel Hydrogen. Visit www.nelhydrogen.com to discover reliable on-site hydrogen generation solutions. And welcome to Heat Treat Radio. Whether you're listening to us or tuning in via video on heattreattoday.com/radio, we're glad to have you with us. If you remember from last year, we released a special episode called Heat Treat Tomorrow, Hydrogen Combustion, Our Future or Hot Air. A panel of 5 special guests joined Heat Treat Today publisher Doug Glenn to discuss the future of hydrogen combustion. In this episode, we'll return to the same question. Do heat treaters need to be ready for hydrogen combustion, and if so, how? Doug will introduce the 5 guests in the panel shortly. Let's get started.
Well, we'd like to welcome everybody to a second round of hydrogen combustion. We're going to have a discussion about hydrogen combustion here on Heat Treat Radio, which is now really a Heat Treat Radio and video. We're welcoming back some of the same folks that talked with us about 1 year ago about hydrogen combustion. So I want to do some reintroductions in most cases, and we've got one new participant on the panel this year. So let's introduce John Clarke. If you want to raise your hand, just to let everybody know who you are there. This is John Clarke, is the technical director and owner of Helios Electric Corporation, a Fort Wayne, Indiana-based company that specializes in energy and combustion technologies. John is also a regular columnist for Heat Treat Today, which we appreciate, by the way, and has written 12 articles with our publication in a series called Combustion Corner. So John, I want to thank you and welcome. Next, Justin, if you don't mind, kind of indicating there, Justin's our newbie on this one, not a newbie to the industry, of course, but to this panel. Justin Dzik from Fives North America is the manager of business development at Fives North America with a special focus in combustion engineering. Justin has written technical articles about ultra low NOx combustion technology for the steel industry and is closely involved with spearheading the advent of a thermal process combustion tuning solution that leverages industrial Internet of Things, IIoT, and Industry 4.0 technology. So Justin, welcome. Glad to have you with us this time. Next is Jeff Rafter from Selas. Jeff is the VP of Sales and Marketing for Selas Heat Technologies, the company being out of Streetsboro, Ohio, Jeff being out of somewhere in the lovely state of Wisconsin. And Jeff has a rich history in combustion industry, including many years with Maxon Corporation, 29 years of industry experience in sales, research and development and marketing, combustion application expertise in process heating, metals, refining, and power generation. Also 11 years of service on NFPA 86 committee, and holds patents for ultra low NOx burner design, and is an IEA member as well, by the way. Next is Perry Stevens. Perry is the principal technical leader for the Electric Power Research Institute, called EPRI, and among other things, currently leads the end-use technical subcommittee of the Low Carbon Resource Initiative, which is a collaborative effort with GTI Energy, formerly known as Gas Technology Institute, and nearly 50 sponsor companies and organizations, which is aiming at advancing low carbon fuel pathways on an economy-wide basis, hopefully towards the achievement of decarbonization. And Perry is also an active member of the Industrial Heating Equipment Association, or IEA. Finally, our guest, we wanted to bring someone in, as we did last time, Joe Wuenning from Europe. Joe is the president and owner and CEO of WS Therm Process Technik GmbH in Germany, and also WS Therm Process Technology here in Elyria, Ohio, in the States. Joe's company has been on the cutting edge when it comes to hydrogen combustion, and Joe's company is also an IEA member company. So there we go. Gentlemen, welcome. Thanks a lot. So let's just start off. Jeff Rafter, I'm going to start with you if you don't mind. It's been about a year since we spoke last. So the question is, and I'll address this to all of you, okay? We'll throw this one out to Jeff first, though. What's changed? Last 12 months, have we seen any major changes in hydrogen combustion technology application? Anything?
I think I would say probably the dominant change over the last 12 months has just been general interest and momentum. We're now seeing inquiries and interest from a variety of different industries, a lot of people preparing for the future, starting to think about decarbonization in a bigger sense, and then watching that interest be amplified by geopolitical events, I think is, obviously a later discussion question we'll talk about. But we're now getting to a place where parts of the world sincerely have more motivations. It's now just not an environmental protection motivation, but we're also seeing really a need to continue operations as fuel supplies in some parts of the world have now become called into question.
Yeah, yeah. Okay, good, good. Let's go to Joe next, and then after Joe, we'll jump over to Perry. Joe, what do you think? Any major changes in the last 12 months?
Of course, here we are closer to Ukraine-Russian war. Germany is directly very much dependent on Russian gas, and is a real fear here for companies that they have to shut down in the fall because of gas shortages. So that intensified, of course, the thinking about the future. One issue which becomes less important is the price. At the moment, the people think, do we even get gas, and don't think what it costs for. Before, it was a big discussion if prices would go up by 5% or 10%. Now everybody's happy if he will get. And so basically we have no more jobs within Europe, where that is not a point of discussion. What can we do? Some people think about electrifying, of course, but we still produce electricity from gas. So that is not really also the solution alone. And we don't know what the electricity grid will do in the future. So flexibility has become a major player also, besides. So not only hydrogen, but can we go also ammonia? Can we do other things? What are the options which keep us independent and doesn't make us dependent so much on one source as it is now at the moment?
Yeah, good, good. All right, let's go to Perry and then over to Justin, and then John will finish up with you. Perry, what do you think? Last 12 months?
So I would echo what Jeff said. I think we're seeing not only sort of a general greater interest, but the leadership of Fortune 500 companies, which are global in nature, and seeing all these geopolitical situations occur, wanting to think through stabilizing their future energy supplies, and understanding the impacts of climate, are beginning to really push down to their suppliers a desire to decarbonize all of their final energy pathways. And so they're beginning to make inquiries in terms of how they can change over equipment and what needs to be done. From a technology standpoint, we're beginning to understand a bit more what elements of hydrogen combustion or blended hydrogen with natural gas, for example, have impacts on what parts of overall systems, and what areas may have significant cost or performance impacts, for which we may need to do a bit of additional research. So we're beginning to understand where those impacts may be as well. And I think finally, we're beginning to see some results of research that sort of tells us on an economy-wide basis, the drivers for demand for hydrogen, and sort of under various scenarios, how much hydrogen might be needed for various economic sectors, including the industrial sector.
Okay, okay. Justin, how about you? Now, you weren't with us a year ago, but if you can take your imagination back to about a year ago, what have you seen change on the hydrogen combustion side of things?
Right. So honestly, what we've seen is just the growing acceptance across not only just industry, but government and society, that we need to transition from, where we are with natural gas or conventional fuels to lower or zero carbon intensity, right? So obviously, depending where you are in the world, the exact timeline varies, but there's increasing focus on how we get from where we are to where we got to go. And obviously, hydrogen is the pure non-carbon footprint fuel. So that's obviously the ideal state. We've also received an increased amount of inquiries and interest in hydrogen, specifically on combustion equipment. And not only just from industry, but from utility companies, even here in the States, talking about blending fuel and putting hydrogen in the natural gas lines and what effect that has on industry, as well as some of the residential implications it might have going forward for their users.
Yeah. Okay, great. Thank you. John, how about you?
I believe we're kind of living through that old Chinese curse. May we live in interesting times, because we have seen disruptions both on our energy supplies, our energy costs. In the U.S., we were tracking Henry Hub prices approaching $10. And now all of a sudden, then we had a fire in Freeport and the price of natural gas fell 30%. But I think the long-term trends, and the trends are being recognized by everybody, is that we are in an international market, not only for oil, but for natural gas as well. So, I think we've seen the effect really come home. The other thing that's going on too is the price of gasoline and transportation in the U.S. has skyrocketed, and we're now experiencing the kind of prices that that Europe has lived with for years and years and years. So I think all these factors, these externalities, are going to drive interest in any alternative. Hydrogen, but is for combustion, but hydrogen also for fuel cells, for automobiles. We're kind of entering a period where I think our technological focus needs to be all of the above. And I think there's an acceptance throughout industry and industry leaders that that's the path we have to be on to protect our businesses going forward.
Yeah. So it seems like the consensus basically is from a year ago, the interest, and to a certain extent, some of the technology is advancing, but at least the interest is very much being advanced. So it's becoming more and more of an issue. Let's talk specifically, and Perry, I'm going to address this one to you first, if you don't mind. Have we seen in the last 12 months actually any new applications and or industries that are aggressively adopting it? There's one that pops to my mind. It's been very obvious, but I'm going to turn it over to you.
Probably the one you're thinking about is the steel industry, I think, has, and it's a specific nuance of steel production that huge amounts of fossil fuels, natural gas, coking coal are involved in the production of raw steel. And so that reduction reaction, hydrogen can serve as a chemical reducing agent. And so it not only introduces thermal inputs, but also serves as a thermochemical reducing agent to actually remove the oxides from the ore that allow you to liberate pure iron content that eventually becomes steel. So it's plus a significant amount of process-related emissions that come from steel production make it a target industry. And so they've been fairly aggressive, particularly in Europe, with a couple of projects where hydrogen is involved. And the fact that there are, as we grow the use of steel, high-strength steel, in a lot of applications globally, there will be a need to add new iron units into the system. A lot of steel is now recovered scrap steel that's melted through electric arc furnaces, but we need to add additional iron content. So direct reduced iron processes are beginning to take a close look at hydrogen as a reducing agent and also for thermal inputs. Quickly beyond that, in most industrial settings, there's a lot of mobile equipment, and that mobile equipment uses a variety of diesel, compressed gas, propane, so forth. And those applications have a particularly easily converted to hydrogen type applications because they're relatively small size and captive space. They compete with electric equipment in that space, and so those two technologies will come forward. As far as other industries, the petrochemical industry uses a lot of hydrogen. They're used to it. They're continuing to look at both liberated hydrogen from process and other sources of hydrogen for their in product production for process heating, as well as inputs into the production of various synthetic fuels and other synthetic products that they make in the petrochemical industry. So those are the two, steel and petrochem, in my view, probably most aggressively looking at hydrogen. Others may have other experience as well.
Okay, that sounds good. Justin, let's jump over to you next on that question, and then Joe, we'll go to you after that. So Justin, new applications, anything of that sort you've seen?
Yeah, absolutely. To echo what Perry said, obviously the steel industry with their Green Steel initiative is really pushing forward. From our experience, a lot of interest is coming from the aluminum industry as well. We play heavily in the aluminum industry, specifically on the melting side, and some major companies are interested in adopting hydrogen firing, especially the ones coming out of Europe. And really their interest really comes from what happens when you fire hydrogen fuel and it interacts with the molten bath. There's a lot of material concerns with hydrogen, right? Not just in aluminum, but in titanium firing as well. Those types of metals tend to have an affinity for hydrogen, which could have obviously a detrimental effect on the final product. So really there's pilot scale tests, full scale tests, all kind of undertaking right now. Obviously the focus is in Europe, but a lot of European companies have plants in the US. So we're seeing a lot of that kind of drift into our territory here, and obviously being focused out of the European headquarters.
Yeah. Okay. Yeah. Joe, how about you?
Yeah, we see a lot of projects right now are running now in the last 12 months. So we have various customers which told us they want to try out of whatever, if they have a furnace with 100 burners. So 2 of them run with hydrogen and see what happens, see what the emissions are, see what the burner life is. Do they have wearing parts? That is a part we do with many customers, quite inexpensive, just try and see what happens. And then we have 2 big research projects where we can do it in a more thorough manner together with the university, really also not only switch to hydrogen, but also to see what happens if we switch back and forth. So if we have hydrogen coming in, it goes to hydrogen, it should automatically adjust without human interference. And that is a little bit more challenging, but we see no real major problems towards that, because of course we will not have hydrogen as a cheap fuel tomorrow, but we have to introduce it slowly. If we have excess electricity, convert it to hydrogen and then get it into the grid. But therefore the burners and the systems have to be able to handle that, the changing compositions, not only switching but also the changing compositions. On the other hand, we're using hydrogen now in our lab for quite some time, and the people in the lab really, they get more and more used to it. I think they think it's more and more rather the better fuel than natural gas, cleaner fuel, the more they work with it. And I think not really too many people are concerned now that it could be a replacement if the hydrogen would be widely available.
Yeah, which is an issue. Being easily available is an issue. I'm sure we'll talk about that a little bit more. John, how about you? Let's talk about any new applications, new industries that are adopting.
The thing I've seen is it's a little off the core of your question, but I've seen a couple of municipalities dealing with some of their distribution challenges. And that I've seen in the last year, where they've recognized that hydrogen is a potential opportunity to save on carbon emissions, but what would it take and what percentages can you introduce? What kind of impact will it have on common appliances? So that is a trend too. And I think the middle between the production and the utilization is going to be a serious challenge for us in the US. And it's an impediment if we're trying to advance the front we have to advance on all three fronts simultaneously if we're going to achieve an effective market. So I've seen some very encouraging work now being considered at the local distribution level.
Yeah, I think we talked last time. I forget, maybe it was Jeff Rafter. I can't remember if you brought it up about some of the distribution snags that we might see in New England with what type of old pipe or something like that. That's wood pipes or something. I forget what it is, but yeah. So go ahead. It's your shot, Jeff. So you go ahead. Any advances, and you can comment on that if you'd like.
Sure. I guess I would say what's different is that the dominant pattern over the last couple of years that we've seen is primarily most of the interest came from energy or from industries that were highly energy intensive, which usually travels with a high temperature process. So it goes without saying that many of the early adopters were glass, steel, other metals. But what we've seen in the last 12 months is now a general interest shift. And we're starting to field inquiries and take on demonstration projects and things that we would traditionally consider low temperature heating, baking applications, foods production, metal finishing. And it tells me that, again, momentum is building. I think in general, industry is beginning to be comfortable with the concept of decarbonization and low carbon fuels, whether it's ammonia, whether it's hydrogen. But again, I think the recognition is that we're only going to get so far until we see some more significant advancements in the generation of hydrogen and the distribution of hydrogen. Again, I think that remains probably the largest hill that we have to crest before we really get through some significant decarbonization impacts.
Yeah, it seems that everybody really loves the concept. It's just the matter of producing it and getting it where it needs to be. Just a quick question to follow up on this one before we move on to the next question, which John, I'll address to you first, and when we get to the next question, but just real quick, lightning round here. Has anybody seen any significant application of hydrogen specifically in heat treat, whether it be a commercial heat treat or a captive heat treat? Jeff, have you seen anything? I mean, I think the answer, I don't know that I have, so I'm just curious. Have you seen anything, Jeff?
Nothing specific, and I think I'll take an attempt at explaining why. And I think it's because so much of the heat treat application, is really dominated by commercial heat treaters. I think they own the bulk of most of the capacity. Where end-use companies do indeed have internal or vertically integrated heat treat, we have seen some interest, but nothing yet in terms of meaningful commercial activity where we've seen commitment to projects. A couple major industrial manufacturers have brought forward projects and studies, but nothing online that I'm aware of, at least in our space.
Okay. Joe, how about you? Anything in the heat treat specific? Just briefly.
Yeah, heat treat industry, like I said, single burners, of course, no complete heat treat shop will switch to hydrogen, simply too expensive. But we don't need to switch, convert whole operations. We can take one or two burners and see that it works.
Yeah, gotcha. Justin, how about you? Anything specifically in heat treat?
No, we haven't had anything in heat treat, mainly for the reasons I think John has already highlighted. It's yep.
Yeah. John, how about you? Anything specifically you've seen in heat treat?
No, but I would like to also point out that our heat treaters use a lot of hydrogen as an atmosphere, and they use it chemically rather than as an energy source. So I think when the price comes down, they will jump very quickly on the use of hydrogen or hydrogen blends for furnace atmospheres to replace endo or nitrogen methanol atmospheres.
Yeah, Joe, did you want us to add something? And we'll jump back over to Perry.
Just a comment that makes it, of course, easier since many of the heat treaters have their hydrogen tank available. So making tests is not really getting the hydrogen. It's then more expensive for a little while, but they can run the test for a week or so, and that's done then pretty easy.
Yeah, gotcha. Perry, anything specific in heat treat?
The answer is no. We've not seen or heard of anyone. Primarily because of that, there's a lot of inquiries around direct electrification as an alternative, but that doesn't work in every case. There are a number of scenarios where that's not a viable decarbonization pathway, and so we need to continue to pursue this as aggressively as we can. But at this point, the market price of hydrogen, and I'll add the sort of working out a reliable supply chain of hydrogen, because right now tube trucks is probably the only way you could really deliver hydrogen reliably to a remote heat treat shop. So there's a supply issue there as well.
Yeah, yeah. And just to unduly poke fun at Perry, you're the only guy on here that's allowed to mention electricity and get away with it. Okay, the rest of us don't even like that topic. So, all right, John, I'm going to jump over to you on this question. May or may not apply to you in this case, but your company. What have you specifically been doing, developing, encouraging, let's say, over the last 12 months? So this is kind of a time when you can, tell people what your company is doing.
Well, as far as technology, nothing like my colleagues on this roundtable. We have spent and spend a good deal of time running economic simulations for major users.
Okay.
So we still act as consultants. We're I wouldn't say we're laying the groundwork, but when the economic data can be put in, we'll be in a position to better and more rapidly provide people good, accurate feedback as to cost of switching and cost of implementation.
Okay. I think you and Perry kind of are maybe a little bit more on that side of the consulting side. So it'll be interesting to see what Perry has to say. But let's go to Joe next. Joe, what has your company been doing? And Justin, we'll jump over to you after Joe.
Yeah, at the moment, we are doing two things. One is installing a bigger ammonia tank, because we want to get into using ammonia as a form of indirect hydrogen combustion. Do we need to crack it first? Can we use it directly? How far have to purify it? These are questions we want to resolve and do in-house. That is one thing. And then also to improve our hydrogen supply, we will install an electrolyzer. We have a lot of solar on our roofs. So it's not directly our business to produce hydrogen, but we want to have the knowledge to tell also our customers, does it make sense to produce your own hydrogen on site? Should it come from the pipeline? What are the options here? So we want to be prepared for that.
Okay, great. And then Justin, over to you, then Perry, and we'll finish up with Jeff.
Right. So as of about 2 months ago, we just fired hydrogen on our regenerative burners. This was in an effort to supply data for our talk at AIST or AIS Tech in Pittsburgh back in May, where we sat on a panel about decarb. So from that, we are actually in the process of breaking ground on installing a permanent hydrogen facility to supply our lab with hydrogen fuel for all our test furnaces. From what I've been told, we're looking and aiming at about 10 million BTU an hour as the max capacity. So we'll be really focusing on not only the burner's ability to run hydrogen, we'll focus on the markets, obviously steel and aluminum first, because those have shown the greatest interest, what burners actually go on those, testing the burner's ability to run hydrogen. But also we're going to try to really look at the material impacts, that hydrogen has on heating and as well as metallurgy, to try to help some of these end users, because obviously this is a huge shift going from natural gas to hydrogen. So over the next year, we hope to make significant headway in our hydrogen studies and our conventional burners here.
Okay. All right. And Perry, how about you? What are you seeing?
From a purely industrial perspective, we have a handful of projects that we're working on now. They are essentially down selecting the most viable pathways for industrial process heating through alternate energy carriers, whatever those might be. So we have sister groups within our low carbon resources initiative that are looking at the production and transportation storage of hydrogen. So whether that is the electrolysis of hydrogen from water, whether that happens to be the use of steam methane reformation with a carbon capture scenario associated with that. And we're looking at the cost and performance of all of those particular pathways, and looking at that for a couple of different sizes of steam boilers, as well as direct combustion, which I think is the primary focus here, and a variety of different types of furnaces, ovens, heaters, and a variety of different types of burner configurations in order to assess cost and performance of those, and then begin to do the techno-economic analysis to determine where these technologies might compete as we project the cost and delivery and storage costs of hydrogen into these locations where, regionally where these industries may be located. So we're doing all of that work to basically circle the wagons around the most important research that we need to do going forward. We're also involved in an oxy-firing project with GTI Energy, which is looking at right now natural gas, but also evaluating how oxy-firing. Of course, if you electrolyze hydrogen, you liberate a lot of oxygen from water, and that oxygen is valuable and can be a very important constituent in oxy-firing combustion, which has a variety of advantages, whether you do carbon capture at the source or you're just trying to improve the overall thermal efficiency of the process. So that's some areas that we're working on right now.
All right, great. Jeff, how about Selas? What's been going on the last 12 months or so?
Well, I think the last year has really just been a continued pattern of counseling customers on applications and in specific what particular burner styles are appropriate for utilizing hydrogen in different processes. But I will say the other topic that's starting to garner some of our attention and efforts is thinking forward about codes and standards as an enabler for more of industry to get interested in decarbonization. And realistically, while burning hydrogen is relatively easy, the handling and distribution of hydrogen has yet to really permeate the codes and standards that we use on a daily basis to govern design of products and processes. Again, it's not unknown. It's used in other industries for other purposes like heat treating, like refining, but we need to bring that knowledge into our codes and standards and really kind of pave the highway for industries and customers to be able to convert without a significant amount of, white sheet of paper engineering.
Yeah. Are you still involved with the NFPA? Is that the type of standards you're talking about, like the 86s and things of that sort?
NFPA 86, obviously 85 if you drive into the boilers world, 87 if you go into process heaters.
Okay.
So, yeah,
Are you still involved with that? I know it says you have done that in the past, but
no, I am not currently on the committee.
But you know enough about what's going on in those. So
We'll return to the panel in just 1 minute, but first, a word from our sponsor. Frustrated with your hydrogen supply chain? Experiencing price hikes, supply allocation, and delivery delays? Reliable on-site hydrogen generation could be the solution to your hydrogen supply problems. Nel Hydrogen is a global, experienced hydrogen generation company, delivering optimal solutions to produce high-purity hydrogen gas on-site. Nel has been producing and deploying hydrogen generators worldwide since 1927. Their patented alkaline and PEM water electrolyzers are designed and manufactured with uncompromising attention to excellence and quality, enabling them to provide solutions that meet the hydrogen requirements for material processing applications around the world, including heat treating, PM, MIM, and metal AM sintering, thermal spray, and coatings deposition. Nel's wide range of electrolysis equipment capacity makes it possible for users from cylinder quantities to the largest of liquid hydrogen users to benefit from the price and supply predictability of on-site hydrogen generation. Nel has the on-site hydrogen generation to match your needs. Visit Nel Hydrogen online at www.nelhydrogen.com and discover how Nel can help you. Now, back to the episode.
that's good. Okay, so a quick question. I don't know, we just need to spend a lot of time on this. And Justin, I'm going to start with you on this one. And that's we talked about it earlier about the steel industry and the fact that they seem to be steel and or aluminum, but steel specifically, I guess. They seem to be one of the early adopters, or at least attempting to adopt it. Specific question here is, do you see what they are doing in the steel industry as having any impact, beneficial and or otherwise, on the heat treat industry at all? I mean, is there any obvious connection between what they're doing and how it might apply to a captive heat treater or potentially a commercial heat treater?
Yeah, I mean, it's obviously you have to have a crystal ball to know what the future is, but obviously I think as the demand for 100% green steel increases, and the green steel producers can, push their will down on scope 1, 2, 3 suppliers, you're going to see all processing steps will need to be decarbonized. That's the future goal. That's the future state. So obviously, if you go down far enough in the scopes, obviously that includes processes for heat treatments of steel. So, who knows how long that'll take, but for sure that is probably the future path in the next, quarter century or so.
Yeah. John, how about you? You see any benefit or any impact of what's going on in the steel industry on the heat treat? And then after John, we'll go to Jeff.
Specifically in the short term, no, but it's like with any technological initiative, often there's unforeseen breakthroughs, unforeseen bits of technology that are developed that are very beneficial. So again, it's the known unknown in technological development. We don't know what it will be, but from experience, we know it's there. So I'm optimistic that something will benefit them, but I can't tell you what it is.
Yeah, fair enough. Jeff, how about you?
Well, I'll take a little bit of a projective throw at this one, and that is I think that experiences in the steel industry will help some types of heat treating, in particular direct fired applications like annealing. When we move to atmosphere furnaces, I think you get to a position where the application becomes so unique that the experiences in steel probably don't translate. So I think there's a couple different bodies of transferability, so to say. When we look at what happens in steel or other industries, I think it's going to be application specific.
Harry, how about you? And then we'll finish up with Joe.
I think the work that the steel industry is doing is interesting from a couple perspectives. One is, how do you supply huge amounts of hydrogen at scale at a cost that is reasonably competitive? And so they're really challenging that outer envelope in terms of how much hydrogen and in what manner it needs to be produced, whether blue hydrogen or green hydrogen, and really pushing forward to ultimately, hopefully, drive the price of hydrogen down, green hydrogen. They're also, I think, helping us to evaluate what we need to understand about valve trains, other supply components and materials, whether that's seals, and at pressure. Obviously, hydrogen has a little quirk of wanting to embrittle carbon steels that may be used for storage or transport, and so work around how to really harden the systems such that those risks can be mitigated, and understanding what it's going to cost to convert when we go to higher and higher concentrations of hydrogen, up to 100% hydrogen as a fuel or a reducing agent. So they're pushing the envelope. The rest of us will be able to take advantage of what they learn.
Yeah. So Joe, I think in Europe, the steel industry is probably a little bit more aggressive than the rest of the world. So what are you thinking about what they're doing there and how it might benefit heat treaters specifically?
Yeah, I'm very happy about that they are moving forward and being proactive. I think it used to be a dirty, complaining, dying industry, the steel industry, and now they suddenly are on the forefront of really changing themselves and really wanted to do that. And I think we will absolutely also profit from that. We see students coming to apply for work from us because they think that's the future, to work in that business. And I think for sure that was different 20 years ago when everybody thought maybe we have no steel industry in 20 years. It might sound stupid, we will have steel industry, but the steel industry presented themselves as being, go to Gary, Indiana, whatever. You don't think that's the future industry, but that is changing at the moment, and I'm very happy about that.
Yeah. Very good. All right. Let's see. I would like to start with Joe. Actually, we'll just start with you. Reverse the course on this one. Talk about obstacles. Let's talk about obstacles. I think it's a very interesting, whether it be production of hydrogen, distribution of hydrogen, other technologies. What do you see being the main obstacles for adoption? And again, if you can tailor comments specifically into heat treat, fine. But I think to a certain extent, where we see it being done in steel and aluminum, probably the obstacle is going to be very similar for the heat treat market. So Joe, what do you think?
I think at the moment, of course, it's uncertainty. The people are a little bit sometimes wait and see because nobody knows. Will it be electricity? Will it be widely available for affordable prices? Will it be other energy carriers? So I think in general, at the moment, of course, here's a lot of uncertainty. What will happen with China? What will happen here and there? It's very different. Some people just now are sitting there like a little rabbit and doing nothing. Other companies are still active and see what their options are. I think we will see a lot of changes into the next decades compared to the past, and it will be interesting times.
Yeah.
But,
Perry, how about you? Yeah, I'm sorry, Joe, is there something else?
No, but I think the uncertainty, that is, of course, there's no clear path where to go. Everybody has to make his own decision.
Right. Okay. Perry, how about you? Main obstacles for the adoption of hydrogen?
Well, it's the big elephant in the room is the price, right? It has to come down in price at the burner tip, to be competitive, or else globally there has to be some agreement, which is very difficult to obtain in terms of sort of regional competitiveness and globally economic competitiveness of industries. And so something has to be done. We have to continue to pursue how we're going to produce hydrogen, transport it and store it, and have it become cost effective at the end use. There are a number of strategies around how to do that, but obviously if you're going to electrolyze it, there's a lot of work looking at how that could be improved in terms of its overall final efficiency. And so that's the biggest challenge. I think the other transport and storage attributes can be overcome technically. I think we kind of know how to do that. There's a big decision, I think, with regard to whether we produce hydrogen centrally and then move it around the world in various modes of transport, including pipelines, which is generally the most cost-effective way, or in some cases, do you produce that in situ? And then the question of whether or not you use steam methane reformation of a fossil fuel and carbon capture, that's a policy matter. I will say this, our first round of studies and sort of bookend scenarios that we've looked at for hydrogen production and use economy-wide suggest that policy matters a lot, and whether or not we allow carbon capture and sequestration will make a huge difference in the degree to which hydrogen penetrates economically markets beyond the very big ones that we've talked about. So if we get into heat treat shops, other end-use applications economically in transport and in buildings, a lot depends on where we end up with carbon policy.
Okay. Yeah. Jeff, how about you? Obstacles?
Well, very similar comments to what Perry had said. It has a lot to do with economics, distribution, and availability. Obviously, the last 12 months has not been a typical economic environment for what we've enjoyed for fuel security the last 40 or 50 years. And I think at this point, nobody has a crystal ball to determine what the relative price of fuel alternatives is going to look like going forward. Obviously, the hydrogen play is still reasonably new from the perspective that we need better ways to generate hydrogen, ones that could put the fuel on par or near natural gas. And as a real world example of that is we've actually seen a resurgence in interest for firing liquid fuels as an alternative to a non-secure natural gas supply. And why? For the simple reason that they're transportable without a pipeline. So it'll be interesting, but I think it's that juncture of economics, supply, and distribution that's really going to be the determinant on where we land 10 or 15 years from now.
Yeah. John, how about you? Obstacles?
For the heat treat area, I think the transportation, heat treats, unlike steel mills, unlike petrochemical facilities, tend not to be co-located. The commercial heat treat and the captive heat treat tend to be distributed, and they're used to being able to obtain natural gas from a pipe on the road. So until we have a means to run more pipe, which is a challenge. It's a very real challenge, especially if you're trying to obtain a new right-of-way. In the US, that's an extremely lengthy period of time. So assuming, and I'll assume for 1 minute that the cost of production, that issue can be dealt with. I think distribution very likely will be a longer term impediment for heat treat in the US. Maybe not so much for steel or other applications.
Yeah, Justin, how about you? Last one here on the obstacles.
Yeah, I mean, obviously, just to echo everyone else, it's cost and availability, right? So cost is extremely, like 10 times what natural gas is right now. So and availability, I think like John said, do we have a pipeline that goes around the United States with it? That's quite difficult. Or do we produce it at site? And then we have to consider the manufacturing capacity, the electrolyzers and the device. If we're going to do it on site, can that keep up with the demand? Operationally, the cost, thermal efficiency and process integration, really those things will help bring down the cost of hydrogen. The other industries like steel and aluminum are advocates of heat recovery right now. They employ it with recuperative technology or regenerative. Heat treaters really don't do that. And I think that is kind of a need when you're switching to hydrogen to try to bring the cost close. It's never going to be equal, but to bring it closer to natural gas, heat recovery is almost a must.
Yeah. Well, production and distribution is, yeah, I mean, that's it. Cost at somebody said cost at the nozzle, how much is it costing? I had somebody, if anybody wants to comment on this, fine. Otherwise, we'll just gloss over it, move on to the last question. But somebody commented and said, I don't know if you've noticed or not, but 3/4 of the earth is made up of water, which is hydrogen, 2 hydrogen and 1 oxygen, right? And he said, I don't know if you noticed, but the bond between those two things is very, very strong. It's very difficult to break the hydrogen away from the oxygen. So almost anything we do to produce it from most abundant source, it seems like would be water, would be very, very expensive. Anybody comments on that?
Just add one additional thought is that in addition to water being widely available, the other challenge you have to have is you're typically looking for a relatively clean source of water to run through an electrolyzer. And if you think about just what you see on the news every night, we already have a challenge where many parts of the world are having difficulty come up with adequate supplies of clean, fresh water. So desalinization definitely has a play in there. But the abundance of water, or hydrogen being the most abundant element in the universe, really doesn't solve our problems. There's still a lot of developmental challenges around the generation of hydrogen.
Yeah. Anyone else care to comment on that before we move on? Joe, go ahead.
Now, regarding the price, of course, that's a little relative. We see at the moment here the natural gas price is triple and quadrupling itself. So the hydrogen price has to come down. But if the natural gas price goes up steeply, that will then make them also equal, just as another level. Not that's what the people want, but it could as well make it much more attractive sooner. If the natural gas price go up. So
yeah, it's all the relative price. You're correct. Any other comments? I think it's a good segue. It's a good segue into our last question, and that is this disruptions that we've seen, geopolitical situations, and what impact that's having on the advancement of hydrogen. So let's just start off. Justin, why don't we start with you on this one? Any comment on the geopolitical situation, how that's helping or hurting the current move to hydrogen?
Yeah, I mean, obviously every day it's changing. So every day it's making a different effect, but obviously the increased upward pressure on fossil fuels due to the environment, the geopolitical environment. There's potential cost penalties for changing from fossil fuel to carbon neutral fuels like hydrogen that may be decreased, obviously. So the desire to maintain the production capability in the face of fossil fuel shortage may further drive switching to hydrogen, hopefully it will, or other carbon neutral fuels. And obviously, or ways to achieve the thermal input needed for the processing steps for all these customers.
Yeah. Perry, how about you? Any comment on the geopolitical situation?
Well, it's unpredictable. I think the volatility of fossil fuels is an issue. The traction that we have at the moment for hydrogen is that ultimately, if we look at the production of green hydrogen, it would come from some renewable source. Now that could be that there could be biofuels that are hydrocarbon based that are produced in natural avenues that are carbon fixing. So they're renewable. But when you look at the green pathway for hydrogen through electrolysis, you got to use electricity. And so the attractiveness to that right now is that there are periods of time where we have a lot of excess power and we need to store that. Batteries aren't a good option for the volumes and timeframes that we want to store that power. And so production and storage of hydrogen so that we can then reuse it either directly as a combustible fuel somewhere or otherwise. And that helps the whole energy system work a little better in terms of periods of higher and lower demand. And so, I think that to me, that's going to be sort of near term, more likely to drive things. I think the geopolitical situations create a lot of interest and realization that we've got to do something. But the changes that are going to have to happen, I don't think they're going to happen fast enough to respond to those kinds of shock scenarios. So this is going to take some time for us to deliver an integrated energy system that takes advantages of low cost power to produce hydrogen, pulls together production and distribution systems that end up working out in a fairly seamless and effective final energy distribution system. So this is not a quick fix.
Yeah. John, how about you? Geopolitical situation.
Well, I think speaking as an American, our geopolitical concerns differ greatly with our European friends. We produce and export 10% of the natural gas, or attempt to export 10% of the natural gas we produce. So we actually are awash with natural gas, while our European friends are not. Even if the instability in Ukraine is settled tomorrow, the question comes up: Can Europe trust Russia long term to be a critical supplier? And arguably, I think you can't. So I think there's going to be a divergence. But even in the U.S., we have a significant political risk that we have to recognize, and that is forming a consensus to put in place the necessary rules, to put in place the necessary legislation to enable this transformation, because we have yet to form a solid consensus in the U.S. that decarbonization is necessary. So there are a lot of, again, I'll use the term externalities at play. And in the U.S., we ourselves, even with all our resources, are not yet in a position to form any sort of coherent plan to tackle this initiative. So I caution people from the political side to keep working on the technology and keep writing your congressman. And
two fronts there. So Joe, give us the unique perspective from Europe on this. Geopolitically, you're going to have a different perspective here.
Of course, John also already mentioned it. Of course, we are in a different position because we don't have our own energy sources. And now I think we are hurt pretty bad by relying on cheap Russian natural gas supply. We thought we will get that forever and very reliably, and that's not the case. So I think we have to diversify. We have to get more own resources. We have to conserve energy, use less, because otherwise we are just depending, and we are not free in our political possibilities if we have to rely on that cheap energy. And of course, to a degree, maybe that is a little different in the US, but being dependent, if everybody goes out on the street, if the electricity shuts off and the air condition cuts down, it's also kind of dependency on certain things. So not healthy for the future. So I think that dependency on cheap energy is dangerous everywhere. And so we should work on that to be here more conservative in using it, using less, using on-site. You can have local photovoltaic, and there have your own air condition on every roof and not depend on the grid and everything. And so I think that would be good. We learned the hard way right now, but I think sort of it wouldn't hurt for the US to do certain things the same way.
Yeah, learn by watching rather than learn by doing, you know? Jeff, how about you?
Well, I think the current geopolitical situation is a reminder that although we've enjoyed, 5 decades of really stable, inexpensive energy supply, it's never guaranteed. It's been quite a while since we had this type of market disruption around fuel supplies, but it's a reminder that fuel supplies and energy really are a worldwide market that are deeply interlinked region to region. So as we look at, potential changes and what's coming forward, I think we have to give a significant amount of focus to where we can make the most impact in decarbonization. And manufacturing really represents, at least in the United States, about 1/3 of all the natural gas consumption. That means that 2/3 of it is power generation, residential, building, and heat. And from that perspective, it kind of echoes Joe's comments that it's multiple technological advancements and market changes at the same time that are going to drive the initiative forward. It can't just be heat treating or manufacturing. It has to be a union of multiple technological changes and adoptions at the same time for heat, power, electricity, and industrial heating.
Yeah, great. All right, so that wraps up the initial questions that you all knew about ahead of time. So I want to just throw out one more. If there was something we were talking about here, you said, this is really something important ought to be said. Did anything like that jump to your mind? Anything you would say kind of as a concluding, or also, hey, let's not forget about this?
Just a reminder that our energy systems, our supply of primary energy, where the energy comes from, and the final end use systems are interconnected by very complex markets and delivery and storage systems, whether you're talking about power, natural gas, fossil fuels, other liquid fuels, and so forth. Those sources, whether you're looking at biosources, have limitations in terms of land use, whether you're looking at hydrolysis of water, whether that be the cost or the impact on water resources and availability, whether you're looking at wind and solar, all of them have their positives and their negatives. And in the end, the marketplace, with all of these various end uses, there's a lot of societal decisions we're going to have to make around who gets access to which sources. As an example, aviation fuel is a very difficult one to replace in terms of a liquid fuel because of energy density needed and the need to carry it along with you. How do we ensure that aviation gets the type of fuel, at a cost that we can all, withstand? And so there's a lot of competition, not just within our industry that we're talking about here, but amongst all aspects of the economy-wide uses of these various fuels, including hydrogen. There will be competitive forces that ultimately will create challenges for where and how we use hydrogen, how we produce it, and where the best end uses of hydrogen specifically would be, or other fuels like Joe mentioned. Ammonia has its interesting potential, areas where it could be applied as a combustible fuel. And so forth. So we just need to understand there are complex economics involved in determining, to what degree hydrogen may end up being a fuel for industrial furnaces.
Yeah, no, good point. Anyone else, something that needs to be mentioned?
John, I would throw in one other comment. Knowing that the audience for most of this presentation is going to be in heat treating, I think perhaps one word of advice would be hedge your bets. Design in and plan for flexibility. Being linked to one energy source is probably not economically advisable for any manufacturing business, at least until markets and geopolitical events settle down.
No, that's a good point. We're back to dual fuel, right? All right, great. Gentlemen, thanks a lot. I appreciate it. Appreciate the update. 12 months. Justin, thank you for joining us this time. Appreciate that.
We hope you enjoyed listening to today's episode with our hydrogen combustion expert panel. Heat Treat Radio is on Spotify, Apple Podcasts, SoundCloud, iHeartRadio, Podbean, and the website www.heattreattoday.com/radio. If you'd like to get in contact with the panel, please email me and I'll put you in touch. My email is bethany@heattreattoday.com. And if you have a new or interesting idea or would like to sponsor a future episode, you can also email me and I'll get you connected. My email is bethany@heattreattoday.com. Heat Treat Radio would like to thank Nel Hydrogen for sponsoring this episode. Visit www.nelhydrogen.com to discover reliable on-site hydrogen generation solutions. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advanced written permission from Heat Treat Today. And I'm Bethany Leone. Thank you for listening.